let's talk about what we've learned so far. You may multiply unlike expressions underneath the radical. Root 2 times root 50, these are not like terms. However, they're both radical expressions, so you are allowed to multiply them and simplify if you can. You may not multiply an integer times a radical expression. This would not be the square root of 100. You may divide unlike radicals. You could do the square root of 50 divided by the square root of 2. That would be the square root of 25, which is 5. You may not divide an integer into a number underneath a radical. Here's your number underneath a radical. Here's your integer. These do not divide. This would not be the square root of 25. Now, if you're still watching, that means that you love learning and you're ready to go on to the next page. We're going to go a little bit quickly. Feel free to pause the video anytime you need to and go back and re-watch to make sure that you understand. So for the next portion, we're going to talk about simplifying radical expressions that involve numbers and variables. The square root of 3a times the square root of 30a is the square root of 90a squared. This is the square root of 9 times 10 times a squared. Well, the square root of a squared is a. The square root of 9 is 3. Only the root 10 is not a perfect square, and so that stays just as is. If I take 3 radical expressions and multiply them together, this would be the square root of 16 times x to the third. Well, 16 is a perfect square. The square root of 16 is 4. X to the third, if you remember from a previous lesson, it's like saying an even numbered exponent times 1 more. The square root of x squared is x, and then root x would be left underneath the radical. I'm going to do this one in a different way. Rather than multiplying everything together, the square root of 12 times the square root of 2 times the square root of 12 with all of these c's, I'm going to show you this as 12 times 12 times 2, and then c times c times c. 12 times 12, there's your perfect square right there. The square root of 12 times 12 is 12, because together these would be 144, which is a perfect square. And then these two c's would multiply together to make c squared. Anytime you have a pair of items, that's telling you that's a perfect square. And we still have 2c underneath the radical. For this last one, it would be the square root of x to the fourth. Or you could think of it as x squared times x squared. We said every time we have a pair of things, that's the same thing as a perfect square. And it can be square rooted. What is the difference between these expressions? The square root of 90 divided by the square root of 10, well, I can simplify this. 90 divided by 10 is 9, so this is really the square root of 9, which is 3. Here I've got the square root of 90 divided by the square root of 10. Well, a radical divided by a radical is allowed. So again, this is the square root of 9, which is 3. And in fact, these two expressions, this one and this one, these are equivalent. It doesn't matter whether you write the radical over the entire fraction or you write the radical over the numerator and the denominator separately. They're the same thing. So if that's true, then I can rewrite this one as the square root of 9 over the square root of 10. 9 is a perfect square, so I can simplify that to be 3. But 10 is not, and that's as far as I can go with this. In the next video, tomorrow, there's going to be a way to show you how to simplify this expression even further so that you don't have any radicals in the denominator. Our summary then is, after you multiply radical expressions, you may need to simplify further. Root 10 times root 5 is root 50, which would be 25 times 2, and that would simplify to 5 root 2. If you have the square root of a quotient, and quotient, that's a fancy word for a ratio, which you'll see as a fraction, I don't mean ratio, I mean like division. You're going to see it as a fraction. If you see a quotient, you can simplify what is underneath the radical first. For example, square root of 100 divided by 5, that's the same thing as saying the square root of 20. And again, simplify that if you can, which we can in this case. The square root of a quotient is the square root of the numerator and the square root of the denominator. So in a case like the root 49 over 100, well, 100 doesn't divide evenly into 49, but I could split this up into the square root of the numerator over the square root of the denominator, and you can certainly leave your expression as 7 over 10. There's no reason to turn that into a decimal.